Scarf, and I'm joined by Summer,
Hi.
Summer Perry. And on today's episode, we are very fortunate to have Doris Kim Sung. Doris, welcome to the show.
Thank you very much. Glad to be here.
Yeah, glad to have you here as well. So, Doris, you are the founder of Dosu Studio Architecture, and you've been bringing some very innovative thinking to sustainable design. You have a very unique perspective that centers around making buildings responsive to their environment. I'd love to get a sense of some of your favorite projects that highlight your design philosophy.
Let's see. I started probably about in 2008 working with a material called thermal bimetal. What that is a sheet metal that's made from two different alloys and pressed together so that they have different coefficients of expansion on either side. Basically, what that means is when the temperature rises, one side expands faster and more than the other, and therefore you get a curl from it. And so I've been trying to use that material for architectural applications. So when you ask a question of, you mean, what were some of my favorite projects, I guess? The first one probably was one of my favorite because it was the most exciting. I had no idea if it would work or what would happen. We combined a lot of computation modeling tools, all the way from design through fabrication, to make the first piece called Armored Corset. And that was just trying to test to see if the material would actually even work at larger scales, because typically it's actually the small coil in a thermostat. And so the application I wanted to do was to use it as a surface material to make a continuous surface by piecing a lot of pieces together. From there, probably, and that was maybe about 2009. In 2012, I did a much larger installation called Bloom. That was in Silver Lake. And that was exciting because it was our first outdoor installation, and it was designed to respond to the sun, like a very large sundial. And parts of it would actually open and shut, whether it was trying to ventilate the area underneath or shade other areas. And that was a really nice project. That was fun to do. And then there's just, various different ones I've done over time. There's another one we did a couple years ago. It now sits at the South Coast Botanical Garden. That was using a much thicker material and trying to curl it at higher heat, like about 300 degrees, and trying to make what's called a pre-stressed surface. So we curl it at high heat. When it comes to room temperature, it wants to straighten and flatten, and so we constrict that from flattening so we get a very stiff combination of materials and very lightweight structural system. So I don't know, they're all fun.
Absolutely. And what is the value of something like you're describing this thermal bimetal that's able to curl? Like what is the what's so exciting to you about that?
Well, the thing that I like about it is it's very passive. To call something a smart material in engineering, it has to actually respond to something without any energy and without any controls. So you have no electricity and no computer chips involved. And so it just reacts by itself. And so the material that I work with reacts to temperature change. So it became really important to me to consider things like that, because when we're talking about architecture, we have a few things that we deal with all the time. And one is temperature change throughout the day, throughout the year, depending on even orientation of the building, whether it's facing the sun or not, as well as even location, in the world. In different areas it's cooler, in other areas it's warmer. So those are factors in architecture that we deal with once we start designing the building, but we don't typically deal with modulating throughout the day. And so I thought by using such a material, maybe we can use it to our benefit and change it and allow it to respond to the outdoor environment. And so that's why I thought it would be really, really helpful. And then it just grew into a lot of other projects.
That's really cool. Can you tell us a little bit more about your design process?
The process, at first, my idea was that it would just be used for shading somehow, that it would open up and then it would close up and shade and do, very simple things like that. But when I started working the material, it got more and more interesting to me because depending on the geometry that we cut it would react differently. And so a little, once you start to understand the material, it's almost like trying to control its behavior just
Hmm.
by the way you work the material. And that's it's kind of an odd thing. And so sometimes I call it more like taming, right? It's like
Yeah.
taming the material and trying to control it.
I
Um, uh, Sorry,
Oh yeah,
you were going to say
I
something?
noticed a lot of the pieces look very unique, like even though they're cohesively creating this one overall gestalt, each individual piece, sometimes I noticed some of them look very unique and I was wondering how you cut them.
Well, I guess the way that we do that, especially when we're making a big surface, is by the use of computational tools or software. There's no way, on that project that I think I mentioned earlier called Bloom, we had a total of 14,000 pieces that made that project. 9,000 of them were the thermal bimetal, and the remainder was just aluminum pieces. And every single piece was unique and different. It uses this kind of attitude more about mass customization rather than mass production. Mass production being something that it's a repetitive process and all the pieces are identical. And by using computation, you're able to, through the modeling tool, identify certain types of parameters so that, if you control certain parameters, and the variables, it will then define all the different pieces and to make them very individual and unique. So in that project Bloom, there were some pieces that had very long, I call them tails, so that that long tail or flap could react to the sun and curl quite a bit.
Hmm.
In other areas of the project that were in the shade where the sun actually would never hit because we connected them again with analysis tools of how the sun moves throughout the day, etc. Those areas in the shade, we didn't need to have longer material, so we shortened it up quite a bit in our model as a parameter, and so therefore can optimize the amount of material that's needed for the project and not overuse material and not have extra material that we don't need, which ultimately contributed to the overall weight of the project and the savings in material. So I don't think I could do it myself computationally when you're talking about 9,000 pieces. Um, but now that we have the computer and capability of doing that, it actually can then produce these continuous surfaces um, and flows that we couldn't do ever before.
That's so cool. It sounds like it's really efficient in a lot of different ways. I read that you
Yeah.
use the Grasshopper plugin for Rhino. Can you tell us a
Yes.
little bit about how the Grasshopper plugin allows you to do your work and how it affects your workflow?
Well, Grasshopper is one of those programs that you can plug in, or not plug in, I wouldn't say, actually put in the different parameters and limitations by design. Um, we used Grasshopper very early. So when we started designing that model, it was at the end of 2010, 2011. And even though that doesn't sound that long ago, it was a
Hmm.
fairly new modeling tool. Prior to that, we used CATIA on some of the early projects, and those were great, I have to say, but way, way too heavy for what we were trying to do, meaning uh, to populate our surface, right? If you're making a surface with all the different pieces in the computer, it took somewhere between 12 to 18 hours just to populate the surface, and we had to let the computer run to do it. Now it certainly doesn't take that much time, and we flipped over to Grasshopper about, like I said, 2011. Um, and it was it was for us kind of a scary moment because no one has ever done it before at that time. And so we ran both Katia and Grasshopper on that project until there was one moment where we think we can make this happen. And so then we aborted Katia, moved to Grasshopper, and was able to again, move seamlessly from design all the way through fabrication
Wow,
with the
that's
same
really cool.
modeling tool. So
Very cool.
that was a big deal for us.
One of the things that I really love about your work is the way that you're incorporating technology that almost gets rid of or obviates other more complicated technology, right? So when you're talking about these thermobimetal facades, building skins that are able to curl and create a sort of self-ventilation for air to flow in and out, as opposed to a more traditional HVAC system that requires a lot of energy to pump air through a building. It's really inspiring. And I'm wondering, how come this sort of design or level of thinking is not more common throughout architecture? And is it simply a matter of because it's more just in the R&D phase and it's so new, or people are aware of this and it's just too expensive? Like, I'm curious where the commercialization and broad use of this new way of creating buildings comes into play.
Cosmo, you asked to be the $1,000,000 question that I've been asking myself and around for the last few years. I can speculate on why I think it might be the case, and there's, I think, many things that contribute to that. I think somehow our society has come to value high tech, basically a lot, to the point where we define high tech by AI, artificial intelligence, or robotics, or more processing capability, more computers, more internet, more of the stuff that seems to dig us a deeper and deeper hole and reliance on computer chips, sensors, robotics, all that kind of stuff. I and I'm not typically, I won't say just now, person that just is all about going back to, nature and back to the beginnings and let's move backwards at all. I actually think that some of the best answers are the simplest ones, right? And if we're really trying to look for things that are sustainable and sustainable solutions, we have to look for the simple ones, the things that will work even if we run out of, or if we're in if we have no energy, or what would happen, if we are in remote areas, or what happened if we don't have the money, or, for underserved populations, all that kind of stuff. I think that's, to me, the goal of how we all should be designing. How can we not rely on computers in some ways? I know it's impossible to really believe that and think that at this point in time. But certainly, why do we have to have so much computers even running our buildings and sensor systems when fundamentally it's just shelter, right? So it's a question that I ask myself all the time, and I ask others, and I don't understand why. I think it's being perpetrated too because nationally a lot of funding goes toward higher tech also. And so the more money that goes into higher tech, the more research that's going to go into the more value system, the more products that will come out that will have the higher tech. And also it will, it's hard to get funding and large amount of funding to support passive systems, to be honest, right? To support things that don't have computer chips, because I think the presumption is it doesn't need money, right? If you need, the money has to go to things that are expensive, and the things that are expensive are, those areas. And so when, we're trying to design things that ultimately in the end will be cheap and affordable and available, and, it doesn't require those things. It just, I think some people might, consider it very backwards or too low tech to support. So I think that's my idea. I think that's part of the problem, but I'm not an expert in there, and I don't think a lot of people are asking necessarily that question, unfortunately.
Fascinating to hear how the way that capitalism is functioning is almost working against, creating more innovation. And it's also interesting
Yeah.
when you use this phrase like high tech. I I mean, certainly, I guess there's different perspectives and definitions around what that means. But I view what you're doing as the ultimate expression of high tech, because it is, um, it's so, it's really like the future of building design and architectural thinking, where we don't have to have such complicated computer systems and technology. I mean, what you're working on is just it's brilliantly simple, and really seems like it's the way that we should be thinking about how to design our spaces for all kinds of spaces going forward.
Yeah, no, thank you. Well put. I agree. Um, and hopefully more people will start to think like that. I think I'm hoping that more people start valuing those types of ideas and
Mm-hmm.
mentalities. But like I say, it's really kind of interesting. Even though buildings are the biggest culprit for both energy use, right? More than industry, more than transportation. I think it's
Mm.
about 40% or so. And on top of it, they're the biggest culprit of carbon emissions,
Mm.
more than automobiles and industry and everything, right? So both in energy use and carbon emissions, it's way ahead, but nobody seems to, be concerned about that. All the money seems to be going into making electric vehicles, into,
Mm-hmm.
reducing, carbon burning industry. Um, but what about all this building industry and construction and stuff? And I know I agree. I'm not saying stop all this stuff, but why aren't we putting a lot more money and research into fixing that as a problem? Right? When
Absolutely.
so much money, as you know, is going into things like autonomous vehicles. And
Mm-hmm.
it's not that I'm against it. I think they're very cool and I'm all for it. But it just seems to be
Sure.
imbalanced.
Yeah. Well, that's an interesting point. And where, in the spectrum of funding towards regenerative and sustainable projects, where would you like to see that money directed? What kinds of areas or topic or projects?
Um, you mean specifically in architecture?
Sure, yeah.
My target first is commercial architecture, mainly because people spend so many hours a day, in commercial buildings, and that's where most of the emissions are coming from. Obviously, a lot of air conditioning,
Mm-hmm.
heating is run,
Mm-hmm.
computers, lighting, all that stuff is done during the daytime. Um, residential, I think, would be the next after that, but certainly is not as big of a problem as commercial. So,
Mm-hmm.
commercial buildings, industrial, um, and again, the ones that are um, most difficult are these high-rise buildings with a lot of glazing, where there's a lot in high cost for lease, and the life cycle is not that great. Those areas are the ones that need, a lot of attention.
Yeah, so when you were mentioning a lot of high tech, it makes me think about how the more computers we use just contributes more to the issue of heating and cooling. And I know your projects are centered around cooling. And I was wondering if you could tell us a little bit more about, like percentage wise, how one of your facades could improve cooling costs for like a large glass building, such as the Willis Tower in Chicago or the Seagram building in New York.
So it's a combination. The windows that you're talking about is probably the invert self-shading windows that I designed a few years ago. It's also a patented product that basically inside the cavity of what's called an IG or an insulated glass unit, which is a double glazed unit. There's a cavity inside that's usually filled with air or some other gases. We're proposing putting some of this thermal bimetal system inside. And basically, that bimetal system reacts to the sun. So when the sun hits those pieces, they'll flip over to ultimately block the sun from entering. It not only, like you're saying, reduces the amount of solar heat gain in a building, and ultimately reduces air conditioning costs by about 15% annually. It the thing that's really nice about it, by putting the shading system in there, we're able to reduce the amount of um, film or low E film that is put on windows typically. And those low E films are typically the things that control the amount of sun entering the building. I'm trying to not use a lot of technical terms, so that's why I hesitate a little. Um, and control the amount of heat transfer through the window. The bad thing about those films is they darken, the surface, and ultimately it's like wearing sunglasses all day long, right? You can tell by looking at buildings, really during the daytime and stuff, you never could see into a building. You know that it's glass, but it's dark and it's colored of some sort. It's found that it's not great for human wellness. Again, you can imagine wearing sunglasses all day long and all you're doing is looking through dark lenses. Ultimately, you get a color spectrum that's very narrow. That's almost black and white. So in our system, because we have the shading in there, you're able to remove a lot of those films and raise the level of color spectrum. So you can almost get full color spectrum when you look out the window. And then the other thing is it's able to reflect indirect daylight throughout the day so that you can get more natural daylighting coming in, as well as a reduction of using lighting because you're getting more light coming in from the outside. So there's certain values to doing that and using it that I think people have never seen before. When these things are flipping over to in the window and the sun, starts to come up in the morning or it goes in the evening, a lot of people equate them to looking at like little butterflies because they just literally flutter and they flip over when
Awesome.
they come through. And so it's actually kind of a cool effect that psychologically we're trying to figure out how to measure because a lot of studies have shown that bringing some kind of nature into buildings also raises the level of wellness for people. And so that kind of brings you a little more in touch with the climate outside because of the time of day that it actually changes, as well as things that are just active and moving, almost like you're in a little forest.
That's beautiful.
So speaking of wellness in relationship to architecture, how does the design of our built environment affect how we feel both on, from a health perspective as well as our mood? I know that you're up to a few different projects that are looking at addressing that issue specifically about around people's happiness and that kind of stuff.
Yeah, so some of the newer projects I'm working on now moves away from the material aspect of using thermal bimetal. What I am more recently looking at is how to use the outside of a facade for public benefit, for public health, ultimately. There's two projects I'm working on. One of them I think you're suggesting is the one about mental health. And so I'm trying to work on these projects of more specifically now, but it's not limited to making architectural panels follow the gesture of a smile, so that in studying what defines that too, without making a happy face, but making gestures and movements using things like bimetal and other things that change, so that people can smile when they look at these buildings. And ultimately, the idea is if we can make one person smile, we can make 10 people smile, we can make 1,000 people smile a day. And through studies, smiling is supposed to improve your happiness. And if we can improve your happiness, then we can obviously improve, public mental health throughout the day. Then ultimately, we can really start to affect mental health in a city on a more massive level. I mean, the thing that makes a difference is that we're not, typically you have to keep in mind that buildings and building envelopes are typically designed to benefit the interior occupants.
Mm.
They can do a lot of things, right? Filter air. They can, you know what I mean, obviously control the sun, like I was saying in previous, you know what I mean, projects. They can do a lot of things to benefit the occupant, to
Mm-hmm.
benefit the owners, the tenants, and cost and pricing and all this kind of stuff. And that's how they've always been designed. But my idea about what architectural facades should do is not benefit just the interior occupants, but to really start to impact pedestrians outside and the general public, and that we can use and turn them into something more useful
Mm-hmm.
than just benefiting the interior occupants. The
Yeah.
other project that I'm working on, which is also kind of exciting for public health, is trying to help reduce the amount of smog in the city.
Mm.
Reduce the amount of smog, which ultimately impacts lung disease and heart disease, especially in underserved populations. And so we're designing smog eating panels
Cool.
that passively, again, without using electricity or other systems, increase the movement of air on the surface and into the surface, so that we can ultimately filter smog from the air and in both particulate matter, sorry, and in gaseous matter too. So that's another project that we're working on, and hopefully we're going to be able to 3D print some prototypes by the end of the summer, and incorporate different technologies and attitudes, so that this might be something that can be 3D printed almost anywhere in this world out of various materials. So.
That sounds really interesting. How will the devices capture the carbon?
The first and main means is by geometry. So the geometry of the surface and the way that we're making these kind of this porous tubular system will capture prevailing winds or other types of wind flow and send it through. Once we can do that and we could increase the air movement, then we're going to try to send them through certain kinds of carbon filters. In addition, we're going to use titanium dioxide and try to impregnate the material and surface area with that substance, so that ultimately it's a well-known product that by use and combination of UV light can actually combat gaseous smog material.
Wow, that's fantastic. Do you have any plans for the carbon waste that would be collected?
Um, you know what? That is a good question. And probably one step ahead too, because there's going to have to be certain kind of maintenance involved. With the titanium dioxide, the good thing about it is the rain itself would actually then remove it off the surface and replenish it. As far as the filters themselves, not sure quite yet, not that far, but the hopes is to try to find again something that's regenerative, or that basically works itself to clean itself as well, so that we wouldn't have to maintain them and clean them out and do things like that. So it's a tough process, because
Mhm.
it takes a while to develop these things. Even though, wow, you think it's like, wow, when can we get this up there and going? It's multiple years before we can actually um, make the product available to the public. And our goal is to just try to get to piloting stage, which we think is going to probably take about 2 years to get to.
Hmm. Why does it take so long? Why does it take longer than you usually expect?
Well, this kind of process is a multi-tiered process. We have a huge team of experts in many different fields. I think I mentioned that we're working with aerospace engineers right now in fluid dynamics to just figure out some of the geometries. And it's funny because typically they work on jets that are moving at Mach speeds, and I asked them why they were excited or interested in working on our project. And to them, it's like completely radical to work with something that was stationary with such slow moving air.
Hmm.
And so they were actually really intrigued by the whole thing and super excited that, you know what I mean, to see that, what they do can also make impact on land. Um, but we have aerospace engineers, we have people from the USC Keck School of Medicine and Preventive Care who
Hmm.
specialize in lung disease from smog specifically. We have uh, other members who are from the Price School of Public Policy to help us, implement that as a policy method. Um, Others in civil engineering, in material development. So you can see that it just takes all these steps to finally get this possible product to work. Right now, we're just in the beginning stage of just figuring out some of these geometries. The next step will probably be looking at how to even simply impregnate the titanium into a material. Um, Hopefully, something that's more cementitious um, in matter, and and again, to what scale, to what size are these things going to be? Um, right now, to give you an idea, we have a tube that we're working with that's probably about 6 feet long as a singular tube. And it's not that we ever anticipated being that big, it just happens to be by geometry. But once we get to a point to get that to work, it's a big question for us whether that's going to be the final geometry or if that 6 feet is going to be scaled down to something that's very micro in size, or if it's going to be scaled up to be something much larger. Like, should it be 60 feet long, on the facade of a building as opposed to 6 feet, or, 6 millimeters? So it's going to take a while, but
So,
it's exciting, it's fun, and I like thinking about it because it's. I think in the end the goal is to make it something not only
Hmm.
sustainable but resilient, right? That through through whatever we do, we design things that again don't need electricity, don't need computer controls, that people don't have to think too hard about how to use it. It just works. So
that's so fascinating.
hopefully.
For determining the size of the geometries, do you do field testing for that, or is the testing computational?
For the size in the end, the scaling up, it's going to be interesting. I think it's gonna come down to numbers, meaning how much the the value of the size versus the amount of smog eating we can get out of it, right? So, for example, if we calculate that we're much better off making one huge, tube on a building, and I don't think it'll get to that, but just for example's sake, and that we have this one huge filter, at one location versus, millions of them that are super tiny and distributed over a bigger area, is going to come down to what is more efficient and more significant as to how it's impacting smog eating in the end. So that I think we'd probably run using computation modeling tools or simulation models um, to kind of calculate what those could be. The other thing that's going to determine it is the size of the particulate matter, too.
Mm.
I mean, because of the size of particulate matter, for example, we can't go down to like nano size because the particulate matter is going to be bigger than the nano size. So there's probably going to be a range of sizes that would work best.
Hmm.
It's fascinating.
Yeah, really
Yeah.
interesting to hear about the specific details on how all this stuff works. I also want to zoom out and get your perspective on where you see the big gaps are in the architectural field as a whole, and where are we failing or not investing enough time or money from your perspective?
Well, it's funny that you asked me that too, because I'm about to start to take over and be director of the undergraduate architecture program at USC.
Wow,
And it's a
congratulations.
question you asked. Thank you. It's a question that you asked that I think also relates to how we educate these students as they, may embark on futures in architecture. And I actually think, just like many fields, architecture is not like what it used to be. I think there's a portion of it that will remain the same, that architects will be the designer of buildings and will be commissioned to do them and continue making beautiful buildings. But I think our industry, like many, has evolved to have many alternative futures to it too. So, for example, which you guys might understand a little better too, is this idea of the digital medium and things like world building
Mm-hmm.
or game making
Mm-hmm.
or I mean, things where it's not really the result isn't necessarily a tangible result like you're building a building, but what you're doing is you're building ideas and futures in movies, in games, in all these different areas. Um, and if these are important, then there's kids now who are born with video games since I mean, yeah,
Right.
and play video games from for the last 17 years, 18 years before they come into college, and so they think more in terms of video games than possibly even in real world architecture. That's the way they see space,
Mm-hmm.
and so how do these two worlds um, balance against each other and also inform one another?
Mm-hmm.
Because those same students who are trained for 18 years playing video games are now going to design architecture. And what kind of architecture are they going to design for the future? Or the entire generation who grows up like that, what kind of architecture are they going to be familiar with and comfortable with and want? And maybe it is something that looks a little more like a game medium. Um, so that's what, or I mean, so that's one thing is I think that we have to really address all these other to touch
Mm-hmm.
into.
Amazing. Thank you. And
Yeah.
yeah, I want to touch on your this transition here that you were a practicing architect and then moving more into research and development for smart materials. And before that, I understand you were involved with biology. I would love to get a sense of your journey to where you are now and uh, why you are focused in uh, this area, this specific sector of sustainable and regenerative design.
Um, uh, that I guess it goes back a while because I grew up thinking that I was going to go to medical school. When I went
Mm-hmm.
to college, I was a biology major. I liked biology a lot. I like the sciences. And when I got to college, and I was talking to my advisor, and my advisor suggested that he said to me, he goes, "Well, if you weren't a biology major and another major, it might look better on your medical school application." And I thought, "Oh, wow, that's a really good idea." And I happened to have taken an architecture class at that time. And I thought, "Oh, yeah, that's pretty easy. Why not?" And then started to flip over to architecture, thinking that that would be my way into medical school. It wasn't until after I graduated from college and was working for a couple of years that I decided to go back to school for architecture. So when I went to architecture, I was much more dedicated going into it at that time. But I think it was also um, after I graduated from grad school, I taught and I practiced architecture for a while, and and you know I was my husband, because he's academic, also he's in medicine, had to move every few years, and
Mm-hmm.
each time I would build my practice or I'd build some reputation or I'd get to a certain point, we'd have to move, and I
Mm-hmm.
had to each time start all over again, and almost reinvent myself. And at that time, it was just so frustrating to just drop everything and then just go again. But I tried to take a really positive attitude from it and thought of it as an opportunity to again reinvent oneself. And so I think by doing that, you start to reflect on what you do and why you do it and how you do it better, so that when you know I think it gave me the opportunity to reflect when you have to kind of clean the slate and start over again. Um, so, in retrospect, I think it was ultimately, serendipity um, that led me to this point, but also the fact that I had to keep rethinking and moving and changing. So, it's one of those things that I know it's hard for some other people because I wonder, thinking way back if I was even in one place and had to stay there and what I mean, the reputation starts growing to the point where it's like, oh, what I mean, it's too hard to leave or change it or whatever, if things would be different, and it might have. It might have. Um, but each time, you know, I could think about what I like and what I think is interesting and start to integrate it. And I think that's why the biology and those things started coming back in because
Mm,
ultimately those are the things I enjoyed even in college and never pursued
hmm.
that deeply, but found ways to try to tie it all back in. So
Yeah. In some of our previous conversations, we had touched on the role of money in finding a career, and uh, how your parents were I don't know if I would say upset or disappointed with your choice in career. I would love to hear your perspective on that.
Um, well, yeah, my parents, again, they were immigrants. They were probably typical Asians, and thought that I should be a doctor too,
Hmm.
and were super disappointed when I told them that I didn't want to go to medical school, and they thought it was just like the end of the world. And I just, it was almost an act of rebellion for me not to do that, but
Mm,
I just really didn't want to at that point in time. I I don't know. I think, and this is where it's I think really hard. I I feel like people, and I did it myself, should kind of go through life to a certain degree a little fearless, um, because if you're just conservative the whole time and worried about things, and especially while you're young, um, I thought things wouldn't happen. Even in my own life, I thought it's like, well, when I'm poor, we don't have money, and and you thank goodness you have a job, but why not just go for things and take risks? And so I think I started doing that very young. Um, and if your heart's into it, if you have passion for it, and if you um, enjoy doing it, then what do you lose in the end? What have you lost? Um, and so that was my belief on how to operate early. And then I think it just has over time paid off. Maybe I don't know if I lucked out
mm,
or or if it amounted to anything, but my attitudes and ideas about biology. It just so happens that biomimicry is very popular now too, right? Maybe
hmm.
it wouldn't be 20 years ago, or it just so happens that we have the ability to do this computation and software because again 20 years ago I wouldn't be able to use a thermal bimetal or
Hmm.
you know uh, you know who knows whether it's the economy or the fact that it's a bad economy too, and I lost a job and I have to do it something else. it's it's in retrospect in my mind that kind of serendipity that things just happen, um, and
Hmm.
whether I'm just lucky or it happened because it was supposed to, I don't know.
That's the ultimate question, right?
Hmm.
Yeah, you mentioned biomimicry, and that's definitely a big theme of your work. And you refer to buildings like a skin. It's a very interesting way of thinking about it. What's the value of biomimicry in architecture?
um, well, I guess first the first thing I have to differentiate is I think people who truly do or um, design things using biomimicry as sources are probably a lot more technical and trying to tie it to some biological source. I'd say that what I do is probably more biophilic,
Mm.
meaning that has this kind of tendency toward of interest to it.
Mm-hmm.
I think it's in my case is probably more a way of thinking, um, a general goal of
Mm.
design,
Mm-hmm.
because biology and ecology and these systems all move together and operate one against the other, but again, in a more how would I say, a more um, ecological or coexisting way, not meaning it's not something that's really forced, but somehow seems to um, come out of a system. So to me, it's more of a way of design and a way of thinking. Um, might be an attitude too. And then, like I said before, it could be just accidental or just intuitive. Um, the thermal bimetal, for example, comes in fairly narrow rolls of material. And in order to make a very large surface out of it, you have to piece together a lot of parts, and or what I call tile them together, sort of like a shingle system. And once you start doing that, I mean, you have a lot of these pieces that then start to be a little more biological in nature too. Things made out of cells and things made out of parts to make larger things. I mean, everything from thousands of pieces of hair to scales to those types of things, and therefore the connection seems to be more automatic, but just by virtue of the system itself. So um, I I like it also, not just aesthetically, because when you look at biology and how these things work, they just work so smartly. How you know what I mean? Um, they they they're brilliant. The design is just brilliant. How can we as humans even ever design something like that? So ultimately, it's more of an aspiration for me to try to look at biology as a way to find answers to things.
It makes me think
So.
about evolution and how evolution shapes how organisms evolve and function in the environment, and how uh, your facades respond to the environment and work with the environment to create this synergistic relationship between the environment and the building. What
Yeah,
other
yeah.
kinds of uh, like biomimicry, or like you said, biophilic designs or systems should we expect to be excited about for the future? Or is there anything that you're looking forward to that's developing right now that the public might want to know about?
Um, I guess some of the stuff that we do in my firm for fun is we make these tiny little robots. And I call them robots just because when I talk to engineers, they refer to them as robots.
Mm.
We just call them little critters that we make out of thermal bimetal.
Oh,
And these little critters basically move where we modulate between hot and cold.
Mm.
They can scooch or they roll or they jump and hop or do all kinds of things. And once we, I mean, and we did these just for fun. They're we don't know how it's going to inform architecture itself. And we'd have these little races, and if you can imagine, when it's requires the sun during the day, it's the slowest race you can imagine because it only takes one step a day. But um,
That's awesome.
but but when we started looking at them, yeah. So when we started um, examining these little critters more carefully, they all had little personality. Not that we intended to design them with personality at the time. So some would like walk like Frankenstein a little, and the other, I mean, some would scooch around like little gorillas, and others would like hop like frogs, and we associate it not only with biology but with kind of personality, and so we'd give them little names. Some of them would be cute, and some of them would be, uh, terrifying, like different thing, different critters. And what it kind of told us is that by controlling these movements, by making them have personality, we really have to think about this for architecture too. In that, if we can make architecture move and make it change and make it operate in some ways, um, it will also have personality,
Mm.
right? And we could then start to have emotional connection to the architecture somehow? Can we, you know what I mean, be terrified by architecture, by the way it moves? This is kind of what led me to the project I was telling you about, that of my happiness project of trying to improve. Because if we don't think about those things, we can also make things that could be potentially detrimental. We can make them depressing, or we can make them terrifying. We can make them, you know what I mean, angry,
Hmm.
and we can actually do the opposite as well. And so this probably taps into one of your other questions too, Cosmo, of, you know what I mean, how, uh, you know, we can change and affect, you know what I mean, the value of a city, um, emotionally, by mental health, by animation, by, you know, I mean, so many different things that architects can now consider a new role, possibly, to what they do. I mean, which on one hand is good and bad. It could be a new position in architecture to try to figure out what mental value we're delivering, mental health value, that is. Um, but I think, again, I think of it as a positive thing because ultimately it's part of the expansion of our profession. It's the potential that um, architects don't, again, have to do what we think architects are meant to only do, which is just design a building and get it built. Um, we now can get into the game of public health, of
Mm.
policy making, of politics, of movie making, of, you know what I mean, and that the expansion of what architects can do can be so much more greater than what we ever thought.
Love that.
So
That's really, really cool. I love what you're saying about envisioning buildings, both from the perspective of each one having an individual character and personality that connects to people on an emotional level, as well as the ability for our spaces to be flexible and moving and flowing. I think that runs very counter to what most people, including myself, come to expect from a building, right? We walk around and they're, of course, these sturdy, stable structures, but by and large, we see a lot of ugly buildings out there. And I think one of the last questions I'm just curious to get your perspective on before we wrap up soon, because I know you have to jump, is, how do ugly buildings get approved, and why do we see so much ugly architecture around us when buildings could be so much more beautiful?
well, I guess first of all, beauty is in the eye of the beholder.
True.
Um, so,
Also true.
but then there's a lot of, I would probably qualify it as maybe bad architecture,
Mm-hmm.
stuff that wasn't really designed,
Right.
or stuff that was poorly designed. And some people can measure it differently. Poorly designed could mean technically, right? The fact that a building's leaking all over the place is bad architecture too.
Mm-hmm.
But the fact that it's not aesthetically appealing is a different question. Um, there's different eras in history too that some people don't like. It's not a
Mm-hmm.
matter of like or dislike, but a matter of quality of design. Um, I, you know, it's it's if it were up to me, I would try to control aesthetics a lot and try to wipe out a lot of bad architecture. Part of the problem, I think, is the fact that there's a certain amount of architecture that doesn't require an architect to design. So residential architecture, you can design your house yourself, and go get it built, and it could be poor design, but you can build it. So a lot of houses you see are not designed by architects. They're designed by someone who thinks they can, do just as well and can get away with it. Designed by contractors, designed by engineers, designed by people who aren't trained by architects. So that, I think, is it's rare when you actually see that great stuff coming out of there, or things that are actually good looking.
Mm-hmm.
Um, but I, it's and if there was an architect and it's a poor design, I guess like anything in any field, doctors who are not good doctors, and there's architects who are not good architects, and I can't vouch for them. Um, but but again, I actually think it's the education of the public, right?
Mm.
The more you can educate the public on the value of design, the better. Um, I think in Europe, in Japan, in parts of Asia, the value of design is much higher regarded than they are in the U.S. Um, I think in U.S. It's a system of cost over design that people value, and so that's why, in general, our buildings don't look as good as they do abroad.
Mm-hmm.
So all these other places, they have competitions for their civic buildings, and they have open of course, in the end, if you open it up like that, you'll have the best designs coming through.
Mm-hmm.
In the U.S., our civic buildings aren't open competition projects. They're open to people who've has the experience of doing that kind of civic building before. So, for example, if you've done a courthouse and you've done 5 courthouses, and there's a new courthouse that needs to be built, it's very likely that the person who's already done 5 courthouses is going to get that commission than anybody new in the U.S. So, and doesn't mean that any of their previous courthouses were good either. It's just the fact that they built courthouses.
Mm.
So it's kind of a systemic problem, um, but hoping it changes, and little by
Sure.
little, little by
Absolutely.
little.
Yeah,
So,
it really speaks to the need for collaborative design and collaborative cooperation and interdisciplinary cooperation for all systems, not just as including architecture, but not just architecture, but a
mhm.
lot of solutions to problems that we're facing in society could be addressed that way.
Yeah, definitely. Most definitely. Um, I think in architecture, our architecture is naturally an interdisciplinary type of profession, um, but even more so now than ever. And the fact that we naturally include so many parts of the of many different professions to inform the design. Um, I'd say definitely even more in demand now than ever before. And I think the nice thing is architects are geared for that kind of future.
Mm. Amazing. Let's end on a positive note here. Um, what is uh what is your high what are your highest aspirations for the potential of architectural design as it relates to solving challenges like the climate crisis or corona crisis or improving our mental and physical health?
I think what you said is exactly it. I that my aspirations is that architecture can solve some of those problems,
Hmm.
and should strive to solve some of our intractable problems in this world.
Hmm.
I mean, I don't know what the answer is. I can't tell you if there's in my mind what it is, but wow, if architecture can help with the basics of shelter, why can't it help with hunger? Or why can't architecture help with filtering water? And I think it can on building surfaces. Or why can't it be designed to grow food? Well, some people are doing vertical farming on buildings. Or why can't it start to unite people? I think it can, right? So I think a lot of things can be
Sure.
done using architecture. And I think the more and more we start to think deeply about what those are, the purpose of it, the meaning um, behind it, and what we can strive to achieve, could be a lot. So I think the more and more people and architects think about that, the more impact we can have overall.
Hmm. Awesome. Well,
Yeah, maybe use literal structural compassion to replace structural violence would be great.
hmm.
Mhm.
Where can people find
It
you
would
and
be
learn
great.
more about your work?
I have a website. It's dosu-arch.com. You can also find me at USC. I'm on the USC School of Architecture faculty. And I also have a startup company called TBM-Designs with an S at the end.com.
Awesome. Thank you. Well, this has been a wonderful conversation. Really appreciate your time, and really fascinating to
Thank you, Doris.
to learn about your
Yeah.
work. For those listening, we'll be back next Wednesday, May 13th, with James Jensen, the co-founder of The Void, which is a really fascinating VR startup, and he's now working on some other interesting things with respect to VR. So looking forward to seeing you guys there next week, and stay safe, stay healthy, and we'll see you soon.
Bye.